Welcome back, my dear pondering people and digital electronic design engineers. So, welcome to the world of T flip flop. So, why we are studying the T flip flop? That's the first question we are going to figure out that why it's here. So, first question of every engineer is starting with why, and then we just don't care, we study everything and then we figure out which thing we have to use. That's all. Having fun. Okay, so let's begin with this. Well, the T flip flop is actually the one input version of JK flip flop. Well, as I told you, well, from my intuitive self, if I may allow myself to brag about a little bit, that there is actually no role for the K. So someone realized it. I feel like that at least. Someone realized it that there is no role for the K. So let's eliminate the K. Let's just take the J. So that's what happened in the T flip flop. So without wasting any time, I'm going to take you to the truth table first and then we're going to design it. Well, in the real life, whenever you think, whenever you learn, you just make the truth table or design first and understand and realize the inputs and outputs. Because arranging the gates is just a matter of few minutes. You can arrange it. We already learned the simplification in our, yes, boolean section, boolean algebra section. So we can simplify. So in this case you just have to focus on the few basic of the things first. Okay, so let's make the clock and the t and q and plus 1. See how clean it seems. Nothing much. 0 1 1, that's it. This is cross, this is 0, this is 1, this is qn previous state, this is gonna be qn the previous state because we don't changed anything, and in the 1 surely we changed anything. That's what 1 means, so we're gonna complement it. Like if it's already 1, if it's 1 it will gonna be 0, if it's 0 it will gonna be 1. That's the whole point of it. That's it. See how simple it gets. That's how I always used to say engineering seems like a Titanic boat, a very big Titanic boat, which means it seems huge when you look from outside. And surely it is huge indeed, but when you dive in and when you learn that this huge thing is having some logic, you understand everything, you just simplify 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 and simplify, and that becomes this easy. Can you believe we are studying the same flip-flop world and we started with these kind of the inputs? Well, if you have noticed, with the time we have it shorter and shorter. Well, this does not seem shorter, but actually it is shorter and the shortest. That's the whole point. So let's design the circuit now. So for this we need two AND gates. Yes, I am increasing the size out of the happiness that, see, if you stick to this point, this is what real engineers know. If you sail through the logic, it will going to be simpler and simpler and simpler. That's the whole point of my teaching. That when you learn, it becomes simple. When you don't learn, no way it will ever be going to be simple. Because you are just, if you're feeling something is difficult, just study a few more hours, few more days, few more months maybe, if you have some time, or just do hard work to cover up that all things. What you are going to notice will going to amaze you, because that will going to be very easy. You might not believe me right now, but that is the reality, my dear friend. Because the things become very easy. With the time, the thing starts repeating. No matter how much insanely big it seems, everything repeats. Always remember my this thing. If you understand few of the logic, few of the basics, like you have learned A, B, C, D, and all that alphabets, and if you know more than one language, you know this thing very much clearly that everything will gonna repeat itself, and that's how we learn the things. Well, as with the talking, I am making it also. I am not even changing the color. Now I know that you will not get confused with the two red colors that what is doing here. Well, I'm going to give the feedback. Well, it's just the JK, right? So we are doing everything as the JK. Just what the speciality is, there is only one input. So this is only one input and we have two outputs. You know that already. We are using only this output for our table purpose. We are just using this output only, and this output, well, it is having physical importance. Well, always remember that I said it jokingly, but if you put the zeros, the series of the zeros and ones and zeros, then it will going to show up in between, because wherever something is not required is handled by him. So this is our silent worker, so we must have to respect it also. But the star is here. The QN, not the star in the sense, this is like if we are watching a drama, this is our director working behind the scene, and this will gonna be our actors team that's going on the stage and perform, or you can call them performers or whatever way you like to call it. So this is the difference. Now I hope you have learned the T flip-flop completely. So I am going to proceed on the last flip-flop. So congratulations, you have just crossed a long journey of the flip-flops. We are on the last step of the flip-flop, which will going to amaze you with its name itself. This is Master Slave Flip-flop. Well, I'm writing it again. I feel like that I should write it again. So this is Master Slave Flip Flop. Well, as its name suggests, that's what actually happened. Yes, you heard it right. Absolutely right. One is the master, the other is the slave. A master slave flip flop is constructed from two separate flip flops. One circuit serves as master and other serve as the slave. That's the most important thing that I want you to remember, my dear friend. And now I'm going to show you that how insanely simple it gets if you come to this long point. Well, in most of the books, what you are going to see for this is just this one. Let me make it clearly. This one and this one. You will amaze with the way I am making it. Q and Q dash. And now I am just connecting few more things. This will gonna give us the input for, and I'm writing S and I'm writing the R here, and this is y dash, the input lines. I'm just adding this is the NOT gate. Whenever we require NOT gate, we are going to use that. Well, it's not technically NOT gate, we are connecting something here. I just let you know, just let's make the diagram first so that we can understand everything clearly. Na, 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 na. Na 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 well, it's already finished. Okay, so if you have learned, well, shortly you have learned, we have learned the SR flip-flop, we have learned the clock, we have learned the NOT gates, we have learned the output, the QN is the present and Q dash is the future output. So that's the master and the slave. So can you tell me that which one is the master and which one is the slave? Any guesses, my dear friend? Well, this is the master and this is the slave. So whatever the master says, slave has to do. Well, it is also controlling the clock. It is feeling like it is having its own clock, but the reality is the clock is coming in this way. So even the clock, even the timing is managed by them. So this is the master slave flip-flop. Using two flip-flops, we just made it that simple. Can you imagine? And now I would like to present you with the clock diagram. Um, okay, let me change the color. Clock diagram. Well, I will explain that what's the clock diagram. No, I am explaining right now that what is the clock diagram. For the R, it will be straight. For the S, it will gonna have a bump up here. For the Y, we are gonna have this one. And finally for the Q, we're gonna have something like this. Well, upside that we are making, like this one, this shows up and this shows down. So this is also down. So what does the up down mean here? Well, very simple. Up is 1, down is 0, 0. So this point is 1, this is 0, 0, and this is 1, this is 0, this is 0, and this is going to be 1. And this is remain the same, means it can be 1 or 0 anyway, whichever way it is. So how the clock is going on? So the real life clock inside the machine goes like this in the square waves. One time it is 0, it is 1, it is 0, it is 1, it is 0, it is 1, and so on. So this is how it works. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Well, in the previous truth tables, what we were doing is we are just putting the 1 and 0. Like in the clock, we always used to write 0, 1, 1, 1, 1, 1, 1, 1. So it is just like it seemed to me at least, why we are even writing it. Just say it's active or inactive, that's it. What is the need to write that all? But in the reality, this is the situation, that's why we were writing that there. So we were getting the outputs on these points. That's what it meant actually in the previous conditions. And with this all said, we already studied the SR flip-flop, so we just completed our work. When master is enable the clock, that time slave is disabled. Well, can you imagine? Let me write this line. This is very interesting. Uh, since the clock input is given directly to master, the clock input is directly given to the master, as we have seen in the diagram. As you can see, the clock input is directly given to the master. Okay, it's directly connected in both the directions, so it's directly connected. So clock is directly connected to the master, but complemented but complemented complemented before applied to slave, before applied to slave. It means if the clock is saying 1 for the master, it will say 0 for the slave. Well, that's so bad. That's why it is called a slave. And this arrangement prevents both master and slave to work at the same time. So the conclusion that we need to draw here is master and slave Never work together. Never work together. Don't take it personally. Well, that's my word. Don't take it personally. Master and slave here only means with master and slave. Well, you are the master, my dear friend. You are the master. And what is the slave? You are working like a slave. You cannot live with the highest of your mentality with lowest of your work efficiency. That's the most inspirational thing I have learned from the master slave flip flop. Never work together. And when the clock, what it actually means is when the clock for the master is one, or we can say active, at the same time the clock for the slave is zero or inactive, and vice versa. So that's the matter of the fact. So when your king's mentality or expenditure is on, you cannot work like a slave. Like you are going to a five-star hotel and you are just waiting for your dish to being served. Are you going to get that dish by yourself? Well, mostly not, actually not. They are the peoples in the hotel. They are specially there just to serve you. So when you are the master, you're not the slave. But when you are the slave, when you work on anything, on your own project, on your company, on something exciting that makes you, excites you cannot be as the master. You are learning it. And to learn, it takes the time. So that's the whole thing about the master and slave. And that's the end for the flip flops. So we have learned and explored through all the kind of the memory of the digital logic design. So you just learned the flip flop, which can make you able to design the memory. Remember, we started with very early that the flip flop stores 1 bit. Well, let me show you that how much you have actually learned and gone through, so that you can inspire your own self that how much you actually have studied. And we started with these three simple points, that this is the flip-flop. Just 1 bit of storage and one flip-flop. Just add the billions and millions of flip-flops and you have millions of bit for the any combination of the work that you wish to do. And these were the things and the logics that we have made, worked and worked. So this is all for the flip-flops, and I'm also going to add especially the short notes covering all the zeros and ones points, so that when you study that by yourself, when you sit together with your notes and you study that what happened when master will stop and slave will work, what happened when s is 1 and r is 0, and what happened when d is working, not working, clock is working, not working, for these all kind of the questions. Because what I presented you is the fact, straightforward fact. So that's what I presented you. But in that short notes, you are able to see everything, every of the input, and that will hardly take you 10 to 15 minutes to revise. Well, that's a good practice itself. So that's it for the flip flop, and reached to the last portion of our digital logic design, which will gonna be, well, you have already seen that, counters. So we will encounter our counters in the next one. Till that time, take care, God bless, and see you in the next one.